Here is the June 2016 C3 paper. In question 1, we need to get an expression for tan 2 theta, knowing that tan theta is p. Now the formula for tan 2 theta is 2 tan theta over 1 minus tan squared theta. So if tan theta equals p, then tan 2 theta is 2 tan theta over 1 minus tan squared theta. Now in part B we need cos squared theta, so we can use the fact that 1 plus tan squared theta equals sec squared theta. So 1 plus p squared equals sec squared. Cos is 1 over sec. So therefore cos theta is 1 over the square root of 1 plus p squared. In part C we need an expression for cot theta minus 45. So that's 1 over tan theta minus 45. So what we get is 1 over, and then we have tan A minus tan B over 1 minus tan A tan B, which is 1 minus tan theta over times tan 45 over tan theta minus tan 45. But tan 45 is 1, so it's 1 minus tan theta. Tan theta we're told is p, so it's p times 1 over tan theta, that's p, minus tan 45, which is 1. In question 2 we've got the function fx equals 2e to the x minus 5, which we need to sketch. So e to the x, of course, is this. So e to the x minus 5 is translated 5 down. So when x equals 0, f of 0 is 2 times e to the 0, that's 2 times 1 minus 5, so that's minus 3. So the graph does this. That's not very good, it doesn't curve upwards. So it's like that. And then we've got this point here, this line here rather, is the asymptote. So the asymptote is y equals minus 5. This point here we've worked out is 0 minus 3, and we need this point here. That's when f of x equals 0. So if f of x equals 0, then 2e to the x minus 5 equals 0. So e to the x is 5 halves, so x is ln of 5 halves. So this point here is ln of 5 halves 0. This is the x-axis, this is the y-axis. Now in question 2, part A2, we've got to sketch the graph y equals mod f of x. So it's the same as before in that this happens, but then it bounces. So instead of coming down here, it goes up like this. Instead of y equals minus 5 being an asymptote, y equals 5 is an asymptote. This point is still the same point, which is ln 5 halves 0, but this point is the reflection of this point here. This point was 0 minus 3, so this point is 0, 3. Now comparing the two graphs, which is what we need to do in part B, the graph is the same for this part of the graph but it's different here. In part 1 it was down there, in part 2 it's up here. So in this part of the graph it's the same. So in other words, x is greater than or equal to ln 5 halves. In part C, we're told that mod f of x equals 2. So in other words, mod of 2e to the x minus 5 equals 2. Just going back to the graph, if you remember, we had that. So at 2, we've got this point here and this point here. This point here is the normal function, this point here is the negative function. So therefore we have 2e to the x minus 5 equals 2, or we have minus 2e to the x minus 5 equals 2. This is the normal graph, this is the reflected graph. So therefore e to the x is 7 halves. In other words, x is ln 7 halves. Or in this case we've got minus 2e to the x plus 5 equals 2. So 2e to the x goes over this side, 2 goes over that side. So we've got 2e to the x equals 3. Therefore x is ln of 3 halves. And these are the two solutions. So for question 3, we've told that g of theta is 4 cos 2 theta plus 2 sine 2 theta, and we're told to write it in the form r cos 2 theta minus alpha, which is r cos 2 theta cos alpha plus sine 2 theta sine alpha. Now 4 squared plus 2 squared is 20, so we can rewrite this as 4 over root 20 cos 2 theta plus 2 over root 20 sine 2 theta. Let me compare these two. There's 2 theta, and here's cos alpha. So from that we can say that cos alpha is 4 over root 20. 3 dots, there we go. So from that, alpha, we need alpha to 2 decimal places, so let's just bear in mind we may be doing some work later on. So it's 26.565 degrees, which is 26.57 to 2 decimal places, but if you need this later on in the question, we'll use 26.565. And then let's explicitly state that r equals root 20. Now, in part B, we need to solve the equation 4 cos 2 theta plus 2 sine 2 theta equals 1. So we know that root 20 cos 2 theta minus 26.565 equals 1. So therefore cos 2 theta minus 26.565 is 1 over root 20. So therefore 2 theta minus 26.565 is inverse cosine of 1 over root 20, which is 77.1. In fact it's 77.079. And then the other angles that we get, because the cosine curve is this, we're going to get minus 77.079. Bear in mind that the values of theta are between minus 90 and 90. So now we've got these two equations to solve. So we need to do 77.079 plus 26.525 divided by 2. So that works out to be 51.8. Or we need to do minus 77.079 plus 26.565 divided by 2, and that works out to be minus 25.3. And as requested, that's to 1 decimal place. Now in part C we're told that this equation has no solutions. In other words, this equation has no solutions. So that's going to have no solutions when k over root 20 is greater than 1 or k over root 20 is smaller than 1, smaller than minus 1. There we go. So therefore k has got to be bigger than root 20 or k has got to be smaller than minus root 20. If it's not clear, the cosine is always between minus 1 and 1. So this has to be between minus 1 and 1. If it's bigger than 1 or smaller than minus 1, we can't have cosine of it.